Very warm welcome from my side as well, wherever you are in the world. So a good morning, good afternoon and a good evening here from Bingen in Germany. Well, not to lose too much time, I would like to jump straight into the theme, and you see these two beautiful devices here in front of me on the table, which we're going to talk about for the next 20-25 minutes probably. You have seen pictures of them, and now we would like to introduce to you what is behind. And for that reason, I'm jumping straight into our presentation. And I'm going to introduce at first my new friend Herbert to you. And Herbert, this is Herbert. He's a passionate wireless cameraman. And I told him during all the time of development, we work on that now since fairly 2 years, about what we're doing there. And today he will check out the new wireless system meshLINK of Broadcast Solutions. And we will join him. So the first thing Herbert realized, as probably you did as well, why is it divided into two pieces? Why is it divided into a processing unit and into a RF unit? And there is several reasons I would like to tell you about. And that leads to our first innovation already. As you can see, dividing these two units allow us to position the radio where it actually should be, above the cameraman's head, for a much better propagation and for a much better and effective RF coverage. Further on, we provide these radios with up to 4 watt power, and that gives us an never seen before coverage and reach of these units. The unit itself, the radio unit, even it is IP68, is just 475 gram, so for the balancing it doesn't have much effect. But even if we thought about how can we work on that the balance of the camera stays perfect, and this leads to our second innovation. Balance your camera just by moving the radio on a rail to wherever it feels comfortable for you, depending on your setup. Depending if there is if the processing unit is installed on the back, depending on how big the battery is you actually use, and you can balance it on that way. The next big advantage by having these units divided is they can be mounted and used in various ways. Since we only need to have the radio unit on an exposed position, we thought it's a very nice feature that you could put the processing unit, for example, into a belt pack, into a backpack, and some of our existing customers already work with it like this. So just put it in there. You can also put it in your pocket. For sure, you can install it directly on your belt. You can place it on the camera wherever you like. Another area where that is a big advantage is the special camera systems. For a Steadicam, for example, you know how difficult it is to balance the whole system. Now we just need to put the radio on top of the camera, and the processing unit can be somewhere else, as just mentioned, in a backpack, on a belt pack, or down where the batteries are, as you like. The same is for rail cameras, for wired cameras, and any kind of moving systems like helicopters or vehicles driving around. It eases your process of mounting dramatically. And if you think about now, but I need to protect it somehow, you don't need anymore, because we made these units completely waterproof and ruggedized. So all meshLINK devices, regardless if we talk about the radio or the processing unit, are passively cooled and made out of a block of solid aluminium and are waterproof. That allows you to use them in any environment. And this could be very helpful for long-term installations outside, for example. Imagine if you use them together with a PT-set camera outside. It is outdoor capable. So let's have a closer look to these chassis. As you can see, we have 4 connectors on the unit. All connectors are at least IP67 specified, so the video connectors are IP67, the 2 multi-pin connectors are even IP68, and we place 2 solid handles next to them to protect them against physical damages. So even when you drop the unit, you don't need to worry about damaging the connectors. Further on, we gave the unit 16 mounting holes all around the unit, what allows us, for example, to put different kinds of brackets and holders there. And you can find a lot of ways how to mount and place them all around. So now Herbert knew about why have we done it the physical way we did, but he said much more important for me is certainly what's under the hood. Tell me how much is the fish, what is the technical capability of the system. And here we can say our innovation number 4 is we have a real super low latency established with our system. Typically this is measured in glass to glass, and we can proudly announce that we reach down to 45 milliseconds for an HEVC, full HD signal. This was measured with a 1080 P60 signal at 3 Mbit, and this is absolutely sufficient for broadcasting, but with 10 Mbit we see almost no difference in the latency. So this is really incredible fast and gives you a lot of new possibilities for installing and using the system. Let's have a closer look to the connectors we have there. I just said we have 2 video connectors and we have 2 multi-pin connectors. Why do we have 2 video connectors? Because it's really 2 separate video inputs. One of them is even 4K capable, and both of them are 3G capable, and we can run them simultaneously in 3G. Further on, we have one 10-pin multiple connector which goes straight to the radio, and this is very smart as well, because we feed the radio with data and power directly from that unit with just one single cable running up there. It's just a 4mm cable, very easy and comfortable to install. And last but not least, we have a 22-pin connector for a breakout cable, which allows us to power the whole unit. As just mentioned, the radio gets the power from our unit. Further on with GPS connection, further on with audio connection, and 2 Ethernet connectors. To give you a better idea how these breakout cables look like, you see on the left side the direct cable to the radio, and on the right side the breakout cable to waterproof switchcraft connectors, providing Ethernet and the power in. So to summarize that again, we have 2 video inputs which can be used simultaneously. So we have 2 encoding cores, actually even 4 inside the unit. And that means that you can optional run a second video channel in full 3G. We have 422S capability, and also 4K, as just mentioned, in 12G is an option coming together with HDR. So we are prepared for latest broadcast and transmission technologies, and you see that's future-proof even when 4K becomes a real standard. And that leads straight to the next innovation, innovation number 6. We have a switch included in the unit. And now you may ask why. There's a lot of reasons why this is very helpful. Our mesh network is an IP network, and having a switch on board allows you to connect straight, for example, your connectors for telemetry, for voice over IP, for teleprompting, return video, or any other kind of IP application you have or you could imagine to use. To have a closer look what that means, let's have a look what it means for telemetry control. You know, most of the modern cameras provide an IP45 connector for telemetrics. And that means in your setup, take a look on the right side, that box represents your OB-WAN or your command and your control room. And on the left side, we see the mesh unit with the internal switch, allowing us to connect IP devices like the camera straight to the unit. So all we have to do is we connect the RCP to the switch, and further on the switch there is our mesh radio and the decoder. All of them are simply connected to the same switch, and switching that on will automatically allow you to control your telemetrics with your RCP. So innovation number 7 we present you today is that every connection within our mesh network is bidirectional. And that means every link as a bidirectional link allows us complex control applications. For example, controlling PTZ cameras or even complex robotic installations. It gives you the chance for remote controls, as just have seen with the RCP, but certainly other remote controls like steering a drone could be done by that. And it allows you to use more or less every kind of IP-based bidirectional protocols and many, many more. Knowing all that, my friend Herbert told about that his friend Anton, and they decided together that they want to test the meshLINK system in a venue. And so we come to the next point, what is totally different to existing wireless units. We start now to explore the beauty of a mesh network, because each of these participants now, the OB-WAN on the right side and the 2 cameramen on the left side, represent a node within the mesh network. And once we switch that on, we see that each and every device, each node automatically detects and connects any other node in the network and connects to a mesh network. They build a mesh network together. And that means that Herbert and Anton use the same network. They use even the same frequency for their transmission of video to the OB-WAN, but further on for the remote control of their cameras. But each of them has a separate routing, as you can see here. Herbert's signal goes straight to the OB-WAN, and also Anton's signal goes straight to the OB-WAN, the video signal and the communication. So our innovation number 8 is that 2 or even more units can share one and the same frequency. And we can use them not only for the transmission of video, we can also use them for controlling the cameras at the same time, as just mentioned, plus communication, video return, whatever. It's an IP mesh network. And what is really exciting is we still have only one node at the OB-WAN. We don't need to have a separate one for each and every camera link in our mesh network. So this is the first what makes a mesh so beautiful, that all participants only use the same frequency. That means you only need to have one license, one frequency license, even if you run 2, 3 or 4 cameras in your mesh. The next and even more important feature of a mesh network is what happens if one of the links gets disturbed, if we have an interrupted link. So let's imagine that Herbert now goes somewhere into the basement behind a big concrete building, so that he loses direct line of sight and further on the link to the OB-WAN. When I say direct line of sight, the whole system is based on COFDM. We make use of reflections. We don't necessarily need line of sight all the time, but for sure there is a moment, for example, going into the deep basement, where we might lose connectivity to the OB-WAN. But now the beauty of a mesh network is, if that happens, the routing automatically done by the mesh network, going from his node to Anton's node to the OB-WAN. And that will happen even without a glitch. Seamless will be switched from the direct link to the OB-WAN to the forwarded link over Anton. So our innovation number 9 is that each node, regardless if it is part of our meshLINK system or if it is a single radio, can forward signals, because each node is a transmitter, a receiver and a repeater in one. And there is almost no limitation in coverage by that anymore. The example I just gave you, imagine if you go down to the basement, you lose connection, just bring one more radio in between and it will be automatically forwarded. So that gives you a complete new possibilities of production. What does that mean for the real life, for your job? Let's have a look for the maybe most common use of wireless cameras in soccer stadiums or sports stadiums. A mesh network, as we describe it here, as an example, having 4 of our nodes on the corners, on the rooftop of the stadium, would allow you to reach every place you want ad hoc. That means as long Herbert is outside and he has direct line of sight to the OB-WAN, for sure the connection will be direct, as just mentioned. If he moves into the stadium, the mesh network will automatically forward his signal to the OB-WAN by using either the right or the left node in front of the stadium on the rooftop. But what happens if Herbert goes behind the stadium? Even then, the mesh network will automatically forward his signal, in this case over 2 hops, back to the OB-WAN, and vice versa. For sure, controls would work in the opposite way as well. Honestly, this will not happen so many times because typically if you are on a venue like a football stadium or any other kind of a big venue, you will have something like existing IP infrastructure already there. A LAN infrastructure, for example, connected to a control room. Now it becomes even more fantastic. All we do now is we connect our OB-WAN with all these devices, plug the radios, the nodes on the rooftop into the wall boxes existing in the stadium. And what happens now is even more exciting. Let's compare. Down in front of the stadium we have Anton. Anton will directly transmit to the OB-WAN because he has line of sight. And for Herbert, we will have a transmission from his device to the first radio, which is connected to the LAN, regardless which of these it is. And then the signal will be automatically forwarded over the existing LAN infrastructure to the OB-WAN. An installation like that means that we always have just one transmission left, because we just need to transmit to one of the 4 radios on the rooftop and the rest will be done by the LAN. This can be even expanded, you can imagine, for car racing. We place radios all around the race course and connect them by fiber, and any other kind of venue. Wherever we have existing IP infrastructure, we can use it, we can make use of it. That could be also the internet, or that could be also hired fixed lines by your telecom provider. We will see some examples about that later on. When I say later on, all that probably sounds too fantastic for you. Using existing infrastructure, forwarding signals, fully automatic routing and all of that. Is that just theory or does it work? And I can tell you, we use it since longer time. So for example, we did the Super Bowl, the biggest sports event in the world, exactly that way. And as you can see in this case, we even rented the network to 2 different TV stations. They used the same frequency and both of them had been allowed to move all around the stadium, inside, outside, wherever they like to. And we had a safe and clear and fast transmission from everywhere. But think even bigger. Take a look at the biggest party in the world, the New Year's Eve on Times Square. Even here, it was always, people always said, you cannot have wireless transmissions if there's 1 million people on the venue. And we demonstrated it's possible, simply by renting fixed lines from AT&T, bringing some of our nodes into the skyscraper, into the buildings, into offices all around the Times Square. And we had direct transmissions from there to the office and then by direct line to the TV headquarters. So in this case, the reporter team was enabled to do interviews wherever they like on the Times Square, even it is such an overcrowded place at that moment. Don't forget, 1 million people have mobile phones at that moment, but we have been able to do it. And I'd like to give you another example of a use case where it was always said it's impossible. And we showed simply how easy it can work if you use the right technology. It was just recently in the Frankfurt Stock Exchange. The Frankfurt Stock Exchange was always known as an RF fortress. No signal goes in there and no signal goes out there. And there's good reasons, because they have metal-coated windows, twice, inside and outside metal-coated. But what we did is, if you take a look to the picture, there's the columns at the entrance, and we just placed one of our nodes there, forwarding the signals from outside to inside and vice versa. And as you can see on the two pictures, we made it happen with one and the same system, one and the same frequency, working outside and inside. We even had an uninterrupted transmission by moving from outside to inside. So you can see totally new ways of production and totally new fields of coverage we can achieve here, simply with an ad hoc network without further planning. It's just a battery-driven radio we used as a repeater node here in the entrance. And the last real-life use case I'd like to show you happened for the Grammy Awards in Los Angeles with our partner RTS this year in 2021. What you see here is a robot driving autonomously, or let's say you can at least not on a track or on a trail. It can be steered wherever you like, driving free, forward, backward, left, right. There's a mast installed on the unit which can be driven up and down. We have a gyro-stabilized head on 3 axes which is controlled. We have the camera and the lens telemetrics which have been controlled. Further on there was a main video stream with 10 Mbit HEVC and 3 security camera streams, because once you have a remote system like this, you need to see where you drive to. That means that you could steer it even out of line of sight. And now imagine all what you see here on that list was done just with one node and over one frequency. That gives you a real idea where the big advantage, next to all the beautiful things I have shown you now, is with an IP mesh network, because you can do so much more than just transmitting video and control your camera. So that was about the hardware. And there is 2 more things I would like to show you where we are working on in the background for a long time meanwhile, which is called the backend. What we call a backend is a PC which is installed somewhere in that mesh network, and that gives us additional features. First of all, GPS will allow us to see where the radios are moving. Since we have seen that we have huge coverage and huge areas we can cover, it makes sense that we exactly know where our radios are moving around. But what was much more of interest for me was a function we implemented which is called total recall. And you need to understand, since we know we have our own network, we have our autonomous network, and we know exact about each and every link's quality within the network. So we designed a PC application which allows us to record all this data for each and every second and each and every radio and each and every link. So while we are operating the system, everything what is related to the network is recorded. And that allows us an analysis and for sure a permanent improvement of venue setups, because later, once we did our job, we can have a look, how good was the link quality, how much data did we transfer there, how much capacity did the network have at that moment. And this is a never seen before perfect tool for optimization and evidence in your work. This is how the screen looks like our innovation number 11. Review every second of your event. Every data is available afterwards. And now, last but not least, once we know about the circumstances and the environment in our mesh network, we did the next step and we created a real, true adaptive encoding. Since we exactly know about each and every link, about its capacity, about how stressed it is, we designed a software which, according to the stress level, to the airtime we need of the network, the encoders reduce or increase the bandwidth, the bitrate, to ensure that we always have the best available quality. And this is amazing because we do that without any interruptions, without any glitch. There's just a slight change in the quality of the picture quality, but we will have no fragmentation anymore, and much more important, no interruption of the link anymore, down to a very, very low bit rate. And on the other hand, it means once the network gets relaxed again, it will always provide you the highest level of transmission and picture quality. This is a milestone in wireless technologies, because you know, in the past it was always necessary that you decided up from the beginning, do I do the safe way and take a low bit rate to make sure that even if we have a longer distance and it will still work? Or do I want to go for the high quality, but I take the risk that if the link is not sufficient to provide that high data rate, it will be interrupted? We stop that now with the first real true adaptive real-time encoding. There's a lot of adaptive encodings on the market, but none of them can do it as fast as we can do it in real time. Well, that was the 12 innovations I wanted to report you, and since it was such a lot of information, I give you a quick run through all these beautiful things we have done. So, number one was the antennas and the TX power are where they should be, bringing the radio unit above the cameraman's head and allow you to put it on exposed places wherever it's needed. Number two, balance your camera by moving it on the rail to the right position to have a comfortable weight balance of your camera. Number three, waterproof and rugged for every environment. Number four, a real super low latency of down to 45 milliseconds for a 3G HEVC signal. Number five, 2 video inputs simultaneously, allowing you either to have 2 different cameras connected and even 4K capability. Number 5, bi-directional links, allowing you, for example, direct connection of your remote control unit to the camera. Number 7, we have an IP switch built in on board, allowing to add additional IP equipment to our meshLINK system. By the way, even internet could be provided to the cameraman or to the commentary or whatever. So it's an IP link, bi-directional, and you have a switch on site. Number 8, 2 or more units share one frequency. We just need one license anymore. We can use one frequency. Imagine what that means for big sports events, as we have seen, Super Bowl, World Championships, Olympic Games, where there's always a lack of frequencies, but now we can provide, or we can use one frequency for more than one camera unit, and plus doing some controls. Number 9, each node can forward signals, so overcome obstacles, use nodes as repeaters simply just by place them in between. Number 10, use existing IP infrastructure like LAN, fiber, or whatever exists on the venue. Number 11, review every second of your event with our backend for analysis and improvement. And last but not least, again, the first real true adaptive encoding, allowing you to use the maximum of the capacity your network, our network, provides you. That's it from my side. This is what we have been working on, where we are absolutely proud, and I hope we had been able to give you at least a first overview about that amazing new product, that it is not just another video link on the market. It is what we call the revolution in wireless. Thank you very much.